Okay, welcome to Level 1 Science Online with Henny van Vieren.
Okay, hi guys, welcome to our next lesson, and today we're going to be looking at compounds, ionic compounds, and how they become more. So thank you for those of you who did your work yesterday. Please continue. If you haven't finished it, you need to upload it into the due work document. Alright, so if you are working along, I'm going to be starting in the presentation on, according to mine, it is slide 78. It might be slide 77, but it is the NCEA paper of 2014 and ionic compounds. Okay, so let me just set up for that and then we will go further. Thank you. Okay, year 11's, here we continue. So, looking at this, we have magnesium oxide. Alright, they want us to talk about magnesium oxide and aluminium oxide. So the formula for magnesium oxide is MgO, the formula for aluminium oxide is AlO3, Al2O3. Explain why the two formula are different. In your answer, consider the ratio of ions in each of the formula and explain how the ratio is related to the charge on the ions. Relate the ratio of the ions in the formula to the number of electrons lost or gained, because the electrons lost and gained is going to give us our charge, is it not? So let's start with magnesium oxide on this side, and we'll do aluminium oxide on this side. Now they give us in the exam a little handy dandy thing called, not a handy dandy notebook, no, the handy dandy periodic table. Okay, for those of you who watch Blue's Clues, you will know all about the handy dandy notebook. But anyways, so magnesium, here's magnesium right over here. And when we look at magnesium, magnesium is on the periodic table. It is in group 2. And if it's in group 2, we know that it has 2 electrons in its valence shell, which means it wants to give away 2 electrons. So we can put a 2 plus. We can put a 2 plus right there. And oxygen is in group 16. 16 says is how many electrons in the valence shell? 6 of them. Okay, and if there's 6 of them and it wants to have 8, is it going to give away 6 or gain 2? I know, it's going to gain 2. So gaining 2 electrons makes us 2 negative. So, looking at this, 2 electrons goes from magnesium and is transferred to oxygen. And consequently magnesium becomes Mg2 plus and oxygen becomes O2 minus. And is this 2 minus and that, oh, this 2 plus and that 2 minus, are they equal but opposite? Yes, so they cancel each other out. Therefore it is a 1 to 1 ratio. And if it's a 1 to 1 ratio, it is simply MgO. Okay, now let's look at aluminium 2 oxide 3, or just aluminium oxide. This is a 2 to 1 ratio. Do you see? I'm sorry, it is a 2 to 3 ratio. Why would it be a 2 to 3 ratio? Let's look at aluminium. It sits in group 13, 13. How many electrons in the valence shell? 3. So I'm just going to move this down a bit. We'll go here. We'll start with Al2O3. Okay, so aluminium, I just said it is in group 13, so it wants to give away 3 electrons, and if I give them away I become more positive, so it's going to be 3 plus. The ratio, as we said here, is 2 to 3. And then oxygen, there's oxygen in oxide, and here's aluminium. So don't forget, they give you all these answers. It's literally right in front of you. Same with magnesium. There's magnesium 2 plus. You can see that's all we did there. And oxide is still there. So, hello. Yes. Okay, so we have aluminium. It's going to be 3 plus for every aluminium, but multiplied by 2, because there's 2 of them, isn't there? So it means there's 6 plus, if we bring that in. And oxygen, there's 3 of them, but let's first say oxygen is 2 minus, but there's 3 of them, so it becomes 2 times 3 is 6 minus. So 6 plus is the charge on this side, and then 6 plus is the charge on that side. Interesting. So that means that 6 electrons went from here, aluminium, and then bound 6 electrons to the 3 oxygens. And that is because oxygen can only accept 2, whereas per can only accept 2 electrons per ion or atom to form an ion. And aluminium can can give away 3 per atom to become the aluminium ion. Hence why the ratio is 2 to 3, because the common denominator is going to be 6. And we'll take it from there. So you see there 6 and 6. Another way to look at it is, so there you're actually explaining the charges, and you are explaining the number of electrons. So I believe that is the question answered. But look at this carefully. We had aluminium and oxygen. Okay, aluminium is a 3 plus and oxygen is a 2 minus. And remember the swap and drop thing we said? So when you swap and drop, this 2 goes down here and that 3 goes down there, and that then becomes Al2. The 2 from there went down there, and O3. There we go, based on the charges. Alrighty, so that's the swap and drop method, but that's kind of backwards where we're from now. Okay, so let's look at the model answer for magnesium. Let me just get rid of all this. Come on, wipe out please. She said that the model answer from the NCEA. You can see there, step 1, charge of the ions. Magnesium is a charge of 2 plus. And oxide ion, so oxygen, has a charge of 2 minus. So step 2 is neutral component. Magnesium is neutral. Magnesium oxide is neutral. So a compound overall has no charge. Therefore, the plus 2 charge of magnesium ion cancels out the negative 2 charge on the oxide ion. And so therefore, the ratio of the ions is 1 to 1. Step 3, movement of electrons. The charge on the ions arises as the magnesium has to lose 2 electrons in order to have a full outer shell and get its charge of 2 plus, and oxygen has to gain 2 electrons in order to have a full outer shell and get its charge of minus 2. Okay, so we said all of that. I'm quite comfortable, but that is how you're going to write it in words, guys. And this is an excellent question. Just simply, they give us the answers right there. Amazing. Okay, so part B, so now she's going to talk about aluminium oxide. And remember we said aluminium oxide. So aluminium and oxide. So Al2 oxygen 3. We said that it had a charge of this side of plus 3. No, don't erase. Plus 3, and on this side it is minus 2. Okay, and that's why you need 2 of these to satisfy 3 of those. so that goes up, I said. If you look at it, it's going to be plus 6, and this one is going to be minus 6. Therefore, they are balanced, and a molecule like this is a balanced molecule. Let's just see what she said. So step 1, the charge of the ions. Aluminium has a plus 3, and oxide has a charge of minus 2. You have to have a neutral compound, so the compound overall has to have no charge. 2 aluminium ions with a combined charge of plus 6 are required to cancel out the charge on the 3 oxide ions with a combined charge of minus 6. Step 3. Movements of electrons. The charge on the ions arises as aluminium has to lose 3 electrons in order to have a full outer shell and get a charge of plus 3. And oxygen has to gain 2 electrons in order to have a full outer shell and get a charge of minus 2. So here's the following question. Write the formula for the following ionic compounds: calcium chloride, sodium nitrate, and zinc nitrate. So let's start with calcium and chloride. So calcium, you know, sits in group 2. So how many electrons does it want to give away? 2. So it's going to be calcium. There's calcium there, and it has a 2 plus up there. Chloride. Chlorine sits in group 17. And if you're in group 17, how many electrons in your valence shell? 7. And how many do you want? You want 1. So the ions that it will create is going to be Ca2 plus and Cl minus. But remember, to have a compound, it has to be balanced. So if you're lazy, you can swap and drop. So it's going to be Ca, Cl2. But you need to understand why we do that, and it's because there's only one negative and there's 2 positives. So only one negative over here and 2 positive, because this one wants to give 2 electrons to go that way. 2 electrons is going to go over. So we need 2 chlorines, because this 2 makes it 2 chlorines, so the 1, so here's another chlorine then, so 1 goes there and 1 goes there. Okay, and then we have calcium chloride. Next one. Oh, and by the way, remember there's calcium, you can see it's 2 plus, and chloride is Cl minus. Unfortunately in the exam you won't have the word there, you're going to have to know it. Okay. Sodium nitrate. Sodium nitrate. What is a nitrate? I wonder. So, nitrate contains nitrogen. So, let's start with sodium. And sodium is right here, so that's in group 1. How many electrons in the outer shell? 1. Let's check. Sodium is there. Okay, so we have Na, and it is a plus 1, or we can write the plus there if we want to make it the ions. Okay, and then nitrate. Nitrate contains a nitrogen, so oh, look at that, there's nitrate, and that's going to be NO3 minus. Oh, that's cool. Plus 1 minus 1. That is a 1 to 1 ratio. Yippee! So it's going to be simple sodium nitrate. Last one they ask us is zinc nitrate. Zinc. Oh, zinc is not on there because I've got a abbreviated periodic table, but zinc is over here. You can see there's Zn2 plus. So Zn2 plus, and we're going to have a nitrate again, NO3 1 minus. So if this one wants to give away 2 electrons, we need how many of these? We need another one to neutralize so that we have a neutral compound. Okay, so you can simply, if that was only that, that is a 1, remember, so you can swap and drop and just say Zn NO3, but here's the trick, has to be in a bracket put a 2 there, because remember this bracket said, hey, here's another one, another whole ion. So one electron goes up here and one electron goes there. Alrighty. Let's check what's her model answer. CaCl2, that's what we said. And NaNO3, that's a 1-to-1 ratio, remember, which I said. And then zinc is going to be ZnNO3 bracket 2. So that is a 1 to 2 ratio. Alrighty, easy peasy. Next one. Again, an excellence question. Determine the ionic formula of the compound that forms when aluminium combines with chlorine and when aluminium combines with sulfur. In your answer, you should consider the ratio of the ions in each formula and explain how the ratio is related to the charge on the ions. Relate the ratio of ions in each formula to the number of electrons lost or gained. That's what we're doing all the time. Okay, so aluminium and chlorine, aluminium and sulfur. So bring in our periodic table. Aluminium is in group 13, 13. So how many electrons in the outer shell? 3. So aluminium is going to be 3 plus if it forms an ion. And look there, that's aluminium right there. Then first one is aluminium and chlorine. Chlorine is in group 17, and if it's in group 17, it's got 7 valence electrons and it needs 1 electron. Okay, so the ratio, well, we don't do the ratio yet, but if you go swap and drop, it's going to be AlCl3, because that 3 from the aluminium goes down here and the 1 from the aluminium. But we know this 3 means that there's 3 chlorines. So it needed 3 chlorines so that the 1 electron can go to the first one, the second electron to the second one, and the last one to the last one. That is why it is a 1 to 3 ratio. Because to cancel out 1 aluminium ion has a charge of 3 plus. To cancel that out, we need 3 chlorine ions. And the 3 electrons, as I said, 3 electrons from aluminium goes to 1 chlorine ion, another chlorine ion, and forms another chlorine ion. Hence you have aluminium chloride. Okay, then we'll look at aluminium and sulfur. So again, aluminium, we know that's 3 plus, and sulfur, where is sulfur? There it is. So it is in group 16. That means it's got 6 electrons in its outer shell, and with 6 electrons in the outer shell, we want 2. So sulfur is going to be 2 minus. How do you get them to talk to each other? A 3 and a 2. Again, if you want a 2, you can swap and drop. So it's going to be aluminium. So aluminium 2, sulfur 3. But we need to know why those numbers are there. And that is because aluminium, the common denominator between them is going to be 6. So we need 2 aluminiums. Okay, that is what that 2 over there means. To combine with 3 sulfurs, because now how many negative sulfurs do we have? Negative 2, negative 4, negative 6. And that balances out with aluminium, plus 3, plus 6. So these 3 electrons up here, they go, and 2 of them will go to this sulfur. 1 will go to this sulfur. Then 2 of these will go to this sulfur over here, and the last one will go to that sulfur. So that is why we transfer the electrons, and we need a ratio of 2 to 3 to ensure that we have a balanced compound. Okay, let's read the model answer. So aluminium has a charge of 3 plus. In order to have a neutral compound overall, 1 aluminium is required to cancel out the charge of 3 chlorine or chloride ions. with a combined charge of, no, with a combined charge, it's not a combined charge of -6, it's -6, not -3. The charge on the aluminium ion arises as it gives away 3 electrons in order to have a full outer shell. Oh wait, sorry, I'm with the wrong one there. It's chlorine, so it's our first one. Chlorine is 1 negative. Remember, chlorine is only 1 negative. So in order to have a neutral compound overall, 1 aluminium is required to cancel out the charge of 3 chlorines, because chlorine is only 1 minus, with a combined charge of -3. So 3 of them is going to be multiplied by 3 is going to be chlorine. Oh, that's just silly. There's going to be 3 chlorines, okay? And they are all negative. So what is the total charge? -3. Okay, the charge of the aluminium ion arises as it gives away 3 electrons in the outer, from its outer shell in order to have a full outer shell and become more stable. Because it has to give away 3 electrons, each chlorine has to accept 1 electron in order to have a full shell. The ratio of ions required is 1 to 3. Then we looked at aluminium and sulfur, and again the model answer is the aluminium ion has still got 3 plus. In order to have a neutral compound overall, 2 aluminium ions with a combined charge of +6 are required to cancel out the charge of 3 sulfide ions, because they are 2 minus. And when you combine those 3, they will give you a charge of 6. The charge of the aluminium ion arises as aluminium gives away 3 electrons in order to have a full outer shell, because it has to give 3 electrons away, and sulfur has to accept 2 electrons in order to have a full shell. The ratio in the ions required is 2 to 3. We discussed all of that. Okay, so the next one, let's read it together. Write the formula for the following compounds: silver fluoride, potassium sulfate, and calcium nitrate. Can you please pause the video and then do that on a piece of paper for me, please? Okay, welcome back. So first thing we need is our periodic table and our ionic table. So silver fluoride. So where's silver? Ooh, it's not on this little one, but it will be over here. Ag. Silver is going to be +1. Okay, so Ag plus. So it wants to give away 1 electron. Okay, and fluorine, there we go, is in group 17. And if you're in group 17, you want to gain 1 electron. Look, it's 1 to 1. That is a 1 to 1 ratio. 1 electron will go all the way from there to fluorine to make it a negative, and that's why they cancel out and become a neutral AgF. Yay! Easy peasy. Next one, potassium sulfate. Potassium, over here, it's a K for kalium or kalium, which is the German word for it. And it is in group 1, which means that potassium wants to give away how many? Just 1. And there it is. And sulfate. Sulfate. I wonder what sulfate is. Let's look. Now, when it's a sulfide, it's not a polyatomic. But when it's an 8, it's a polyatomic. Okay, so polyatomic 8 is a relatively big number. So sulfate, like the number 8, sulfate, you have to remember it's more than 1 ion or more than 1 atom. So it's a polyatomic ion. Okay, so there's sulfate. If it's an ide, you only have sulfur. So, and look at the charge, it's 2 minus, so SO4, 2 minus. So what is that? That's a ratio of 1 to 2. Okay, if it's 1 to 2, then I need 2 of these to satisfy one of those. So you can swap and drop, and then you have K2SO4. Yay! And it's all balanced because 2 electrons went from 2 potassiums, and it had to satisfy the 2 of sulfate. Now the last one is calcium nitrate. So calcium sits here, it is in group 2, and if it's in group 2, it's got 2 electrons in an outer shell. So calcium wants to give away 2, makes it 2 plus. Nitrate, let's think, la la la, it's got a nitrogen in it, huh? So, there it is. NO3 minus. NO3, and look, it's a single minus. So that means it's a ratio of 2 to 1. 2 to 1. That means that if you swap and drop, the charges are 2 to 1, but the ratio of ions is going to be 2 to 1 over here. Remember, that's the 2. Just ignore that. I shouldn't say ratio, the charges. So the charges are 2 plus and 1 minus. Now to balance them, calcium wants 2 electrons and nitrate can only give 1. So that means we need another one of these. So as I said, you can swap and drop if you wanted to. So this 2 goes down here and that 1 goes down here. So we have calcium, nitrogen, but we need 2 of those. So we put it in a bracket, calcium nitrate. Okay, and now we have a balanced ionic compound, and the ratio is going to be 1 to 2. Alrighty, because 2 electrons, this one had 2 electrons to give, so it needed another one of those, so that 1 electron can go there, and 1 electron can go here. Alrighty. There's the model answer. 2016. Justify the ratio of Na, sodium plus, and oxygen 2 minus ions in the formula Na2O in terms of electron lost and gained and the charge in each ion. Guys, can you see it's the same thing over and over and over? Include an explanation of the type of bonding. Ions. When ions bond, what type of bonding is that? It's an ionic bond. That's interesting. They give you the answer in the question. So, Na plus. What is my charge on Na plus? It's going to be 1 plus. O2 minus. What is my charge? It's going to be minus 2. So, if this one can only give 1 electron, and this one wants 2, how many of this one do you need? You need 2. So you swap and drop, and you get Na2 and O. So our ratio is going to be 2 sodiums for every 1 oxygen. Look, and then they've given you the answer. So, sodium has 2 atoms of sodium became a sodium ion by giving 2 electrons, and that then created oxygen because oxygen is in group 16, so it wants 2, and sodium is in group 1, it only has 1 valence electron available. Okay guys, so again, let's read the model answer, and we need to practice the words. Okay, you need to actually write this in words, so that's why I'm giving you some homework as well. So the sodium atom loses 1 electron to form a sodium ion. However, the oxygen atom requires 2 electrons to fill its outer shell. Therefore, 2 sodium atoms react with every 1 oxygen atom, and you can see it clearly over here. Okay, now my pen just died. The 2 sodium Ions have a total charge of +2 to balance the -2 charge of the oxygen ion, oxygen 2 minus ion. So in other words, an ionic compound has an overall no charge. The bonding attraction between sodium ions and oxygen is an ionic bond formed when the electrons lost by the sodium are gained by the oxygen. Easy peasy. Okay, I believe this is the last one for today. Explain why silver oxide has a ratio of 2 to 1. In your answer, ratio of the ions, number of electrons lost and gained. Explain how the ratio in the compound is related to the charge in the ions. Okay, so there's going to be Ag to oxygen. So how many? That's 2 to 1 ratio. So 2 atoms of silver for 1 atom of oxygen. The reason for that is because silver forms a silver forms a ion of 1 plus, so it wants to give away 1 electron. But oxygen sits here in group 16, so it's got 6 in the outer shell, so it wants 2. It needs 2, and if it needs 2, silver can only give 1, so that means we need 2 silvers to give away an electron each. So 2 atoms of silver will provide 1 electron each to become 2 silver ions. Okay, so they've both given their electron away, and it goes to oxygen. And now oxygen is a happy camper because he is, they become positive because they've given away their electrons. And now oxygen becomes 2 plus. Okay, so again, we need to practice our wording for this. So let's just read the wording. So each silver atom loses 1 electron to form a silver ion, 1 plus. However, each atom of oxygen requires 2 electrons to fill the outer shell. Therefore, 2 silver atoms react for every oxygen atom. In other words, 2 silver atoms lose 2 electrons and 1 oxygen atom gains 2 electrons. The 2 silver ions have a total charge of +2. To balance that, the -2, that is the total charge of a single oxygen 2 minus ion. So the overall ionic compound has no charge. And that is where we'll stop for today. Okay guys, I'll put some work for you to do on under due work, and then please submit it when you're done. Have a great day.